Welcome to the Test 2 study guide for Developmental Math Combined MAT 0022C. Let's go on to the first question. Number 1 says to evaluate the expression using the order of operations. So remember, order of operations is PEMDAS, or sometimes we use GEMDAS. And I'm writing multiplication and division on the same line because this is done from left to right. And then addition and subtraction, you could do that from left to right as well to make it easier on yourself. The reason why we sometimes use GEMDAS instead of PEMDAS is because PEMDAS, the P technically represents parentheses, but the G for GEMDAS represents any grouping symbols. So we might have brackets, absolute value symbols, any of those. The E is for exponents, M and D are multiplication and division, and then A and S are addition and subtraction. So let's go ahead and follow order of operations with this expression. So we look across the expression, and the first thing that we see to be done is this division. Because technically, these parentheses, even though they're grouping symbols, those really just represent a multiplication. And that's the same with the 6 and the 9. Those are really just a multiplication. So we're going to first do the 28 divided by 7, which gives us 4. 7 goes into 28 4 times 4, and then we'll bring everything else down. Again, moving from left to right, we do the 4 times 4 first, which gives us 16. And now again, we want to do the multiplication first. So we're first going to do this negative 6 times 9, which is negative 54. And we bring down the 16. And now we're done with multiplication and division. So we only have the addition and subtraction left. So we have 16 minus 54. We can also write that as 16 plus a negative 54. So they are different signs, so we're going to subtract. So I'll do that on the right over here. We can't take 6 from 4, so we cross out the 5. That becomes a 4. Carry over the 1. 14 minus 6 leaves us with 8, and 4 minus 1 leaves us with 3. So we know that our subtraction of these is 38, but is it positive or negative? And since the 54 is bigger and the sign is negative, our answer becomes negative. So the answer should be negative 38. All right, let's move on to the next question. Number 2, write the English phrase as an algebraic expression. Let the variable x represent the number. So whenever we see the words a number or the number, we're going to write our x there, all right? So let's see what it says. It says negative 5, so let's go ahead and write negative 5 multiplied. So we're going to multiply something here by the difference. So we know that we're going to have some kind of subtraction of some number. There's our number that we were looking for earlier. So we're going to represent that some number by x. That goes first, and 11. And then 11 goes next. So this minus, that comes from our difference. Because remember, difference represents subtraction. And since we're doing negative 5 multiplied by the entire difference, we put that difference in parentheses. So the way that we would write this without that little multiplication symbol would be negative 5 times x minus 11. And that's the same as negative 5 multiplied by the difference of some number and 11. And since it didn't ask us to simplify, we would just leave it in this form. All right, let's move on to the next question. Number 3. Evaluate the expression for the given value or values of the variables. So this is an expression. So remember, an expression does not have an equal sign. So we're going to take all of these variables, and those are going to be plugged in wherever we see the variables. So I'm going to rewrite our expression. That was the absolute value of 8a squared minus b squared plus c. And wherever we see a variable, we're going to plug in a number that's represented by it. So the first one that we see is a, and that's represented by negative 2. So we're going to plug negative 2 into the place where a was. And see how I put it in parentheses? It's very important to do that so that you properly solve this expression. Now we have minus, and then b was 1. So we plug 1 into b, bring down that absolute value symbol. And then we have plus c, and c is 17. So now we're going to go through, and the way that we're going to solve this is by order of operations again. You always want to make sure that you follow order of operations, all right? So remember, P was really also a G, a grouping symbol. So what are our grouping symbols here? Well, we have this absolute value symbol. So that means that we want to solve everything inside the absolute value before we can do anything else. So within those absolute value symbols, let's go ahead and follow order of operations as well. So the first thing that we see is we have an exponent. We actually have two. So we have negative 2 squared. So whenever you square something, you're multiplying the number by itself. So that would be negative 2 times negative 2. Bring down our 8, and a negative, when we multiply them, gives us a positive 4. And then also, we have 1 squared, which is 1 times 1, so we have minus 1. Now the reason why the negative and the negative, there's a little trick that we can do. It's called our tic-tac-toe board of multiplication and division. A negative and a negative gives us a positive. So we want to put pluses down the diagonal of this tic-tac-toe board, and this is going to tell us exactly what you will get when you multiply and divide positives and negatives. So everywhere else, we fill in a negative. So this first column times or divided by the next column gives us the third column. So for example, we have a negative and negative here. So we use this third row, and negative times negative gives us a positive like we wanted. So that's how we find that out. So now also make sure that you bring down your plus 17, and our exponents are all done. So we check that off. And next, we're going to go in these absolute value symbols, and we're going to do multiplication division. So we have 8 times 4, that gives us 32, minus 1 plus 17. So there's no more multiplication or division, so we just go ahead and do the 32 minus 1, which gives us, I'm going to bring it over here, 31 in absolute value symbols plus 17. And what's the absolute value of 31? Now remember, absolute value, if you look at a number line, I'm going to write it up here, the absolute value of any number is just the distance it is from 0. So the absolute value of negative 1, that's 1 away from 0, and the absolute value of positive 1, that's 1 away from 0. So the absolute value of negative 1 or 1, either one, is still just 1 because the distance is 1. So for 31, the absolute value of that number, that's going to be 31 because it's 31 places away from 0. And then we bring down our plus 17, and when we add that up, we get 48. All right, let's go on to the next question. Number 4 says simplify the algebraic expression. So for this question, we also want to follow order of operations. Now there are parentheses, but if we look inside those parentheses, is there anything that we can do here? There really isn't because none of these are like terms. So we don't have any grouping symbols, we don't have any exponents, but we do have a multiplication, this negative 4 times these parentheses right here. And that's called something special, that's called the distributive method. So we're going to distribute negative 4 to both of these terms in the parentheses. So we have negative 4 times 2x, that's negative 8x, because whenever you're multiplying a number times a variable, that just gives you the two numbers multiplied together. So we have negative 4 times 2, which is negative 8, and then carry down the x. And then we have negative 4 times negative 6. Again, a negative and a negative is a positive, and that gives us 24. And then we bring down everything else that was left over. And when you distribute that negative 4, you actually get rid of the parentheses, so we don't need them anymore. That's the whole purpose of distributing. So now let's go ahead and combine our like terms. So I see that we have an x here and an x here as well. And those are like terms. So we're going to combine them. So we have a negative 8 plus negative 4. So that gives us negative 12x. And then we also have left over the positive 24 and the positive 9. And those are like terms as well. So we're going to add those up. So that gives us positive 33. And then there are no like terms anymore, so this is our simplified algebraic expression. That's our final answer. All right, let's go on to the next question. Number 5, solve the equation. It says use words or set notation to identify equations that have no solution or equations that are true for all real numbers. So this one says to solve. So this is an equation, so we're going to have x equals some number if we have a true solution. We're going to have to see if there's no solution or if the solution is all real numbers. We'll have to check that. So again, following order of operations, just like we did in the last question, we don't have really parentheses or exponents to solve, but we do have some multiplication here. We have some distributing. So we're going to do the distributing first. So we have negative 2 times, that's really a 1x. So that's negative 2x. And then we have negative 2 times negative 4, which is positive 8. And then we bring everything on this side of the equation down. So we have negative 82 equals. And on this side, I'm going to distribute this negative 6 as well. We bring down this 4x first. Don't forget that. And then we have negative 6 times positive 1 is negative 6x, and negative 6 times positive 7 should be negative 42. All right, now let's combine our like terms on each side of the equation before we do any moving. So on the left side, there are not multiple x's. We only have this negative 2x, so there's no x's to combine with that. But we do have a positive 8 and a plus negative 82. So these are different signs, so we're going to subtract. So I'll do that on the side over here. Now we can't take 8 away from 2, so we're going to carry. Now that comes a 12 right there. So 12 minus 8 is 4, 74. Now which one is bigger? The 82, so it's going to be negative. And then bring down the negative 2x. Bring down our equal sign. And on this side of the equation, we're also going to combine our like terms. So we have our x's here. Those can combine. So it's positive 4 plus a negative 6. Different signs, so we subtract. And then 6 minus 4 is 2. The sign of the greater is negative, so we have negative 2x. And then the negative 42, there's nothing on that side of the equation that combines with it, so we just bring down the negative 42. Now, we're going to try and get our x's on one side of the equation and our numbers on the other side. So we add 2x to both sides. That way it will combine with this other x, and these cancel out. And look at that, these also cancel out. So now we have negative 74 equals negative 42. There are no more x's here, so we have to look at this and see, is this a true statement? No, it's not. Negative 74 does not equal negative 42. They're completely different numbers. So that means that there is no solution for this equation. Or you can say it's the empty set, either one. All right? Now what if we had something like this? These are the same, right? So if they are the same, that would mean that your answer is actually all real numbers. And the way that you would represent that on an exam would be x such that x is a real number. Because the two sides are the same, so that means that you can plug anything you want into x and you will still get a real solution for this question. All right, let's move on to the next question.
This is question number 6, solve the equation. And we have 1/4 x minus 3/8 x equals 5. So because we are dealing with more than one fraction, I suggest we're going to use the method of eliminating the fractions. So the first step would be that we have to look for the least common denominator. In this case, we have 4 and 8 as our denominators, so we have to find the least common denominator of 4 and 8. That would be a number that both of these numbers multiply into. And the least number that both numbers would go into would be 8, because 4 goes into 8 2 times and 8 goes into 8 one time. So my least common denominator for these fractions would be 8. So I'm going to multiply through the entire equation through by 8. And I can make 8 a fraction as well by putting it over 1. So we have 8. And like I said, we can make it over 1. And then we are going to multiply that by our first term, 1/4x. And then again by 8/1 times our next term, 3/8x. And that is equal to, one more time, 8. And this time we don't have to put it over 1 because our 5 is a whole number, times 5. So now we can go through and we just simplify everything that we can with fractions. So right here, for example, if you look at the numbers diagonal across, you can cross simplify because 4 goes into 8 one time and 4 goes into 8 2 times. So the common factor of 8 and 4 would be 4. And if we look at the next term, we have across 8 and 8. So now the common factor of them is 8. So 8 goes into 8 one time and 8 goes into 8 also one time. And over here, we don't have any fractions, so we don't need to simplify nothing. Now we multiply straight across with fractions. What is left over? So we have 2 times 1x, which is just 2x, and in the bottom 1 times 1, well, a denominator of 1, we don't really need it. We can just ignore it and move on to the next term. So here what is left? We have left 1 times 3x, which gives us 3x. And again, our denominator will be a 1, which we don't have to put. And also our last term would be 8 times 5, which gives me 40. So now we just have a regular equation that we are solving for x. So on the left side, I see these two terms are like terms. We can combine them. So 2 minus 3, there are different signs, which means we subtract the smaller number from the bigger number, 3 minus 2, and then we keep the sign of the larger number, which is negative. So we get negative 1x or just negative x. And that is equal to 40. Now x is not by itself, so we need to eliminate the negative sign in front of the x, and we can do that by dividing by a negative 1, because negative over negative is positive. Our x would become positive, but what we do to one side we do to the other side, so we end up with x on the left, and on the right 40 divided by negative 1 gives us negative 40. So negative 40 is our answer for this problem. Let's move on to the next question. This is number 7, and we have use a proportion to solve the problem. So it says, if a boat uses 21 gallons of gas to go 64 miles, how many miles can the boat travel on 84 gallons of gas? Well, the hint is that we have to use proportions, and proportions look something like this. So now let's read it one more time and basically pick out the information that we are given. So right over here we have 21 gallons for the boat. Let's start with 21 gallons, and I'm going to put the measurement, and then we have 64 miles. So the boat uses 21 gallons of gas to go 64 miles, and I'm going to put my 64 down here. And if I continue reading, what else I have 84 gallons. Well, I started with gallons on top, so also here I'm gonna want my gallons to be, and then in the bottom is going to be my miles. So I'm given 84 gallons, which goes right over here, and then I'm looking for my miles, so I can call this x. I set up my proportion, and there are multiple ways of setting up the proportion, but whatever you do, you just need to make sure that if you have, for example, gallons and then miles, that you're also going to start with gallons in the bottom and then miles. So you need to keep track of your numbers, that they are vertical or horizontal aligned. So now let's solve the proportion by using cross multiplication, which means 21 times x, which is 21x, is equivalent to multiplying the other two numbers, so 64 times 84. Okay, so let's first simplify the right side of the equation, and if we multiply 64 times 84, we get 5,376. And on the left side, we have 21x. And the next step would be to divide by 21 on both sides. And that will be a long division problem. So my top number goes inside 5,376. And then the 21 outside. And then we would start by, these are two digits, so I'm going to take two digits in here, 53. How many times does a 21 approximately go into 53? And I would say about 2 times. So multiplying the 2 times the 21, I get 42. Then I would subtract. So 3 subtract 2 leaves me with 1, and 5 minus 4 leaves me also with 1. So yes, the 11 is smaller than the 21, which means 2 was a good approximation. Now I'm going to bring down my next number, which is 7. And then again, how many times does 21 approximately go into 117? About 5 or 6 times. So let's try 5 times. 5 times 21 is 105. Again, we have to subtract. So 7 subtract 5 is 2, 1 subtract 0 is 1, and 1 minus 1 is 0. So 12, yes, 5 was a good approximation because 12 is less than 21. So we have another number left by bringing down the 6. And then how many times does a 21 go into 126? Well, 5 times it went into 105. So I'm gonna approximate that this time it's going to be 6. Let's try 6. And 6 times 21 is exactly 126. So if we subtract, we get a remainder of 0 and we are done. This means, putting it back into perspective of the problem, that our x value in this case, x equals 256, represents miles. So the boat can travel 256 miles on 84 gallons of gas. Okay, let's go to problem number 8. Solve the problem. A tree casts a shadow 33 meters long. At the same time, the shadow cast by a 0.56 meter tall statue is 1 meter long. Find the height of the tree and round the result to the nearest unit. So I'm a visual person. I'm just going to draw myself a little picture. So the first part of the problem is talking about a tree. So I'm going to draw myself a tree. And that tree casts a shadow that is 33 meters long. And then at the same time, there is a statue 0.56 meters tall. And the shadow cast by this statue is 1 meter long. So I basically can connect the sun ray hitting the statue with where the shadow ends, and the same with my tree. So I basically have two right triangles, and that means again I can use proportions to solve this problem. And if I start with my left side, I am looking for the height of the tree, so I can call this x. So starting with x on top, which is the height, and then I have the shadow of my tree, which I put in the bottom. But remember, I told you in the previous problem that you could have also started horizontally and then you continue in the bottom, but in my case I'm gonna start top bottom. So I have the height of my tree and then the shadow, and then on my second figure, my statue, again the top number is the height, so the height of the statue is 0.56 meters, and then the bottom number would be my shadow, so that is 1 meter. And now I can use cross multiplication to solve this proportion. So x times 1, which is just x, and then 33 times 0.56, and I'm gonna do a little side multiplication for this. And when I multiply decimals, I can ignore the decimal place as long as I'm doing my multiplication. So 33 times 56, and 6 times 3 is 18. 6 times 3 again is 18, plus 1 is 19. And then 5 times 3, I'm adding a placeholder, a 0 here. So 5 times 3 is 15, which is also a 1 up here. And then 5 times 3, again 15 plus 1 is 16. Now I add my two numbers, which gives me 8 plus 0 is 8, 9 plus 5, 14. 1 plus 6 is 7, plus 1 is 8, and 1. So now I have my solution, but I had two decimal places in my original problem. So I'm just going to count two decimal places in my answer. So x equals 18.48 meters. This means that the tree is 18.48 meters tall, but now also there is round the result to the nearest unit. So the nearest whole unit would be before the decimal. So we have to look at the 4. And whenever you have a number that is 5 and above, you round this number up, and it's below 5, then the number just stays the same. So in our case, 4 is below 5. Our number stays the same. So our final answer rounded to the nearest unit would be 18 meters. So approximately this tree is 18 meters tall. Let's go to the next question. So make an approximation based on the conversions given and round to the nearest tens. So I'm just going to underline this to remind myself at the end to round. And then we are given that 1 kilometer is 0.621 miles. And we need to convert kilometers to miles. So we can also use proportions for this problem. And we are looking for this number, so we're calling it x. And we are giving 1 kilometer, so I put it on this side with the kilometer. And we are given that 1 kilometer is 0.621 miles, so I am going to write that on the side representing the miles. And now I can use cross multiplication to solve for my unknown variable. So 5 times 0.621 is equivalent to 1 times x, or just x. And I can reverse my equation by putting the x on the left side. 5 times 0.621, and then I do my multiplication, ignore the decimals, so just write down your numbers. 621 times 5, and 5 times 1 is 5, 5 times 2 is 10, and 5 times 6 is 30, plus 1 is 31. In the original problem, I had 1, 2, 3 decimal places, so I'm going to count 1, 2, 3 decimal places. So my x equals 3.105. And again, I underlined rounding to the nearest tenths. After the decimal, you have your tenths place. So if I'm rounding to the tens place, I'm basically looking at the next place, my hundredths place, and my hundredths place is 0, which is below 5. So 1 stays the same, and my final answer is 3.1. We need units, and we are talking about miles. So 3.1 miles would be 5 kilometers. Okay, let's go to question number 10. Solve the formula for the specified variable. So this is basically the formula to convert Fahrenheit to Celsius, and in this case they want us to solve for C, for Celsius. So I'm just going to rewrite my equation over here, and our goal is to get C by itself. So I'm going to move everything to the other side except for C, and I'm going to start with the number that's furthest away from my C, which is 32. So to move 32 to the other side, I'm going to subtract 32 from both sides. And on the right side, 32 cancels out as 0. And then f minus 32, these are not like terms, so I cannot combine them. I'm just going to write them next to each other. F minus 32, and I'm left with 9 over 5c. Now, I have only one fraction in this problem, so I don't have to eliminate the fractions. I'm just going to deal with them, and I'm going to use the rule of multiplying by the reciprocal to eliminate the 9 over 5 in front of the c. So the reciprocal is just 5 over 9. And what I do to one side, I have to do to the other side. But remember, I have two terms on this side, so I need to make sure I have parentheses. So 5 over 9. And then on the right side, well, if I now use cross simplification, I could cross simplify the 5 with the 5, and it goes into 5 one time, and also the 9 and the 9, the common factor is 9, so 9 goes into 9 one time. And then you see, if I multiply the leftover numbers, I'm just left with 1 over 1c, which is just c. And then on the right side, if you don't find your answer, you may want to distribute. So I would distribute my fraction to the f, and that just gives me 5 over 9f. And then 5 over 9 times negative 32, and I can make the 32 a fraction as well. I have to check if I could cross simplify, but in this case 9 and 32, they don't share any common factors. 9 has factors 3 and 3, and 32 has factors 8 and 4, and there's nothing in common, so we just straight multiply 5 times 32, which is 5 times 2, 10. 5 times 3, 15, plus 1, 16, so 160, and 9 times 1 is just 9. And because we already determined that 32 and 9 didn't have any common factors, I do not need to worry about simplifying this fraction. If it wasn't reducible in this part, then I cannot reduce it over here. So if I wanted to, I can rewrite my equation by starting off with c on the left, and then I have 5 over 9f minus 160 over 9. And now if I was given any value for f, I would plug it in here, and then I could solve to find the corresponding value of Fahrenheit in Celsius.
All right, let's move on to number 11. So number 11 says, solve the inequality, graph the solution set, and write it in interval notation. So we need to solve this just like we would an equation. We're going to get our x's on one side of the inequality and our numbers on the other side. So the first thing that I want to do is get all of our x's on one side. So we're going to first subtract this 5x from both sides of the inequality. So we have 6x minus 5x is just x plus 10. Bring down our inequality symbol, greater than. The 5x and the 5x cancel out, and we just have 15 left over. And now we're going to subtract 10 from both sides. So the 10's cancel out. We have x is greater than 5. 15 minus 10 is 5. So now let's go ahead and graph that on our number line down here. We have a nice number line that we can use. So we have our 5 right here, but this is a greater than symbol, right? So we have two types of symbols that we can use. We can use the closed circle or the open circle. Now because this is greater than, it's not equal to, so we can't use the closed circle. So it actually should be an open circle at positive 5. And it's greater, so which way is greater going? We have our negatives this way and our positives this way. So of course our positives are bigger, so we're going to be going this way, right? That's all the numbers that are greater. Now it asks us to write it in interval notation. So we also have brackets and parentheses. Now in this case, we're not on the 5. So this would be a case where we'd use parentheses. So we start going from left to right, parentheses, 5, comma, and then of course we have our infinities, right? We've got positive infinity and negative infinity on the left. So we go from positive 5 all the way to infinity, and infinity gets a parenthesis. So here would be our representation in interval notation, and this would be our graphed representation of the solution, where x is greater than 5. So they could also write it, instead of with the circles, like this. So you may see it in either representation, either using the circles or using either brackets or parentheses. Alright, let's move on to number 12. Number 12 also says solve the inequality, graph the solution set, and write it in interval notation. So we have actually two inequality symbols. What I'm going to do is whatever I do to this middle part will be done to all three sides. Alright, so we want to isolate the x, and the way that we do that is we subtract this 3 from all three sides of the inequality. So what will happen here is that'll cancel out in that middle piece, and then we have 19 minus 3 is 16, and 31 minus 3 is 28. And then we bring down our 4x. Now to get rid of the 4, we divide everything now by 4. Remember, 4 is multiplied with the x, so the opposite operation would be to divide. So then we divide here by 4 too. So that cancels out over here, and we have 4 is less than x, which is less than 28 divided by 4 is 7. So these are less than or equals. So these are going to be solid circles or brackets, all right? So we have our positive 4 right here, and our positive 7 right here. It says that x is greater than 4, so that means it's going this way, right, from the 4. And then it says that x is less than or equal to 7, so that would be going this way. Remember, this is the positives, and these are the negatives. So again, in this case, we use brackets, so we'd have a bracket like this, or we would have our dots that would be connected by a line between them. So writing that in interval notation, we use this graphical notation to write our interval. So we would start with a bracket from 4 to 7, and then close the bracket. And that would be our interval notation for this problem. So we also have some other cases that you may see. Let's say that we had something like this, where the 4 was now negative instead. So when we have a negative 4, whenever we divide by that, what happens to these little inequality symbols? They actually flip the other way. So this would completely change our problem. And what that would look like, we would have x is less than or equal to negative 4, going that way, and then x is greater than or equal to negative 7, which is going that way. So again, we would have an interval notation like this, moving from left to right, which is just fine, but keep in mind that if you have a negative attached to your x, you're going to either be multiplying or dividing by the negative, so that would always flip your inequality symbols. So the correct answer in this case was this, with this graph. This was just our side work for a different type of problem. Alright, let's go on to number 13. So number 13 says, solve the length of a rectangular room is 5 feet longer than twice the width. So let's say that this is our length, so that's 5 feet longer than 2w, twice the width. If the room's perimeter is 130, so P equals 130, what are the room's dimensions? So we know that this was the length, right? L equals this. Now opposite sides are always the same, and we know that these are the w's, right? So perimeter is just the addition of everything in this rectangle. So we're just going to add up everything and set it equal to 130. So we have 2w plus 5 plus 2w plus 5 plus w plus w. And there's another way that you can do this, but I'll show you that after. So combine your like terms. We have the w's, and then we have our 5's. So that gives us 6w plus 10 equals 130. And we're solving for w, so we subtract 10 from both sides. The 10's cancel out, and we have 120 equals 6w. Divide by 6 to get rid of it, and w equals 20. But it asks for the room's dimensions, so we now need to find L. So we know that L equals 2w plus 5, so we're going to plug 20 in for w. So that would be 2 times 20 plus 5 equals 40 plus 5, so L equals 45. All right? And you may also see, remember perimeter equals 2L plus 2W, so you could have plugged in this equation for your L and solved it that way. Alright, so let's go on to number 14. Number 14 says, solve. If needed, round money amounts to 2 decimal places. Alright, so we need to remember this. And all other amounts to 1 decimal place. So money is going to be to 2 and everything else to 1. So it says an automobile dealership recently reduced the price of a used sports car by 7%. If the price of the car was $41,500, find the sale price. So there are a few ways that we can do this. The way that I typically do it is I find what the sale amount is, and then I subtract that from the original price to find the sale price. So the sale amount would be whatever it's reduced by, so that would be 7%, times 41,500. Now, of course, change your percent to a decimal. So that's 0.07 times 41,500. So let's do that on the side. So we have 41,500 times 7. We're going to ignore the decimal places and then we'll bring them back later. 7 and 0 is 0. 7 times 0 again is 0. 7 times 5 is 35. Carry the 3. 7 times 1 is 7. Plus 3 is 10. Carry the 1. 7 times 4 is 28. Plus 1 is 29. So now we have 2 decimal places. So we're going to move it over 1, 2 places. So our sale amount is $2,905. So now we're going to take the original price and we're going to minus the sale amount. So I'm going to do that over here. So we have 41,500 minus 2,905. And that's going to be the sale price. So we can't take 5 from 0, so we need to carry from the first one that we can carry from, which would be this one. So 10 minus 5 is 5, 9 minus 0 is 9, and then we can't take 9 from 4, so we need to carry again. So 14 minus 9 is 5, and again can't take 2 from 0, so we need to carry. 10 minus 2 is 8, and then 3 minus nothing is just 3. So we don't have any decimal places, so our sale price is $38,595, and that will be our final answer for this question. Alright, let's move on to the next problem. Number 15 says find the unknown value. It says $432 interest is paid when $4,800 is borrowed at 3% simple interest. So this is a simple interest problem. So if you remember that formula, that would be I equals PRT. So it says find the time for the loan. So we're going to plug all of these values in wherever they belong. So it says that 432 is our interest. So that will go first. Equals P, so that's the principal in this case, which is 4,800. That's the amount borrowed. The rate, let's see, do we have rate here? We do, 3%. So we change 3% to a decimal, move it over 2 places to the left. So it's 0.03. So we plug that in right here. And then it says find the time. So time is the one that we don't know. So that's our variable. So we're first going to follow order of operations. So we need to multiply these before we can divide to solve for t. So I'm going to do that on the side over here. So we have 4,800 times 3. We're going to ignore the decimal place again. We'll add that in later. So 3 times 0 is 0. 3 times 0 is again 0. 3 times 8 is 24. 3 times 4 is 12, plus 2 is 14. And this has 1, 2 decimal places. So we have 1, 2 decimal places right there. So we have 144t equals 432. So now to solve for t, we divide both sides by 144. So these cancel out over here, and we're going to approximate. Let's see what happens. I'm going to assume that maybe it's 3, so let me try that. So I'll do 144 times 3 on the side. 3 times 4 is 12. 3 times 4 is again 12, plus 1 is 3. And then 3 times 1 is 3, plus 1 is 4. So that was a lucky guess. So 432 divided by 144 is indeed exactly 3. So it says, find the time for the loan. The loan was 3 years, or t equals 3. All right?
Okay, moving on to the next question. Question 16. Plot the given point in a rectangular coordinate system. So our point is -3, 2, and right over here we have our rectangular coordinate system. We can label the axis. So here that will be the y-axis, and this is the x. And then also when we are given a point, our first value always represents the x coordinate and our second value is the y coordinate. So starting with our x, which is -3 on the x-axis, going in the negative direction to the left, so 1, 2, 3, and then our y value is 2 positive, so 1, 2 up. Right here is our point -3, 2. Okay, that's it for question number 16. You just have to identify then the correct graph that you've been given. Moving on to question number 17. Determine whether the ordered pair is a solution of the given equation. So we are given -4, 6 and the equation, and to find out if this point is on that line, this equation represents a line on the coordinate system, we have to take the point and plug it in. Again, our first value represents the x, our second the y, and then we're just going to plug it in for the variables x and y. Starting with 4, our x is -4, so times -4. Then continuing with the equation, so plus 2, and then for y we have 6, so times 6, and all that is equal to -28. Now we're going to simplify each side. So on the left side, using order of operations, well, from the GEMDAS or PEMDAS, all we have left is multiplication. So starting over here, 4 times -4, a positive and a negative gives me a negative, and then 4 times 4 is 16. And also over here, 2 times 6, which is 12, so positive. Positive times a positive stays a positive. And we have -16 plus 12 is equal to -28. Continuing on the left side, we have opposite signs, so always subtract, keep the sign of the larger number. Larger number 16, I know my answer is going to be negative. And 16 minus 12 leaves me with 6 minus 2 is 4, and 1 minus 1 is 0, so -4 equals -28. And that is not a true statement because -4 cannot equal -24, which means that this is no solution. So this point does not lay on top of the line. If you're thinking about a coordinate system and somewhere there you have a line, remember this may not be a right line, but I just wanted for you to be able to visualize this problem. And you were asked if this point is somewhere here on top of the line, but in our case, because we have a solution that is not true, our point would be somewhere else, somewhere off, outside the line. And obviously, if you are given a point, an equation, and then you get something that is a true statement, that would mean that that point is on top of the line. So that would mean yes for the problem. But in this particular case, it was not a solution because we got a statement that is not true. Moving on to question number 18, and we have find the slope of the line passing through the pair of points, or state that the slope is undefined. And we are given the 2 points -9, 3 and -3, -1. So whenever we have 2 points and we are looking for the slope, you should remember the formula m equals y2 minus y1 over x2 minus x1. And we can label our 2 points. I'm just going to call this one my first point, so xy, and because it's my first point, I'm going to do the little subscript 1. And then I have my second point. Again, I have my x and my y value, and because I'm calling this my my second point, I'm going to put a little subscript of 2. You can reverse those two, just make sure that once you call this one your point 2, you stay with it throughout solving the problem. So now I'm just going to plug in my values, starting with y2. y2 is -1. Then from the formula I have a negative, and then y1, so my y1 is 3. Over x2, my x2 is -3, and then from the formula minus, and then my x1 is -9. So now I'm going to solve the top and the bottom individually. So I get -1 minus 3, same signs, I add, keep the sign, I get -4, and in the bottom I can combine these two signs using multiplication, so a negative times a negative is a positive, and then I have opposite signs, so I always subtract, keep the sign of the larger number. In my case, the larger number is 9, so my answer will be positive, and 9 minus 3 is 6. So with fractions, you always have to check if you can reduce. And in my case, 4 and 6 share a common factor of 2. So I could divide top and bottom by 2. And I get -4 divided by 2, which is -2, and 6 divided by 2, which is 3. So my slope for this problem is -2 over 3. Okay, that's all that we're looking for, so moving on to question number 19, and it states, find 3 ordered pair solutions by completing the table. Then use the ordered pairs to graph the equation. So I have my table, and I am given 3 different x values, 0, 1, and -1, and here I have my equation. What I'm going to do is I'm going to plug in each x value to find my corresponding y value. So plugging in 0, I get y equals -4 times 0 for x plus 5. Anything times 0 is 0, so y equals 0 plus 5, and then 0 plus 5 is just 5. So for my first point, I get a y value of 5. Now I have to do it again for the next one to find my corresponding y value for 1. So plugging in 1 for x, we get y equals -4 times 1 plus 5, which is y equals, so a -4 times 1 is just -4, and then plus 5, different signs, subtract, keep the sign of the larger number, so my answer is going to be positive, and 5 minus 4 is 1. So my y value for the second point is 1, and then I have to do it one more time. So plugging in a -1 for x, we get y equals -4 times -1 plus 5. So negative times negative is a positive, and 4 times 1 is 4 plus 5. And then 4 plus 5 is 9. So my last point is -1, 9. Now, I wished I had a graph already prepared, but I'm going to try real hard to draw straight lines. So this is my y-axis, and then I have my x, and I can mark some numbers. And I see that my y is 9, so I need it actually a little bit taller. So, plugging in my first point, which is 0, 5, so as a point 0, 5, my x value is 0, on the x-axis 0, and then my y value is 5, so 1, 2, 3, 4, 5, right here. And then my next point is 1, 1, so 1 on the x-axis, and 1 on the y. My second point should be right here. And then my last point is -1, 9, so first value is x, negative on the x-axis, and then 9 on the y, so going up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be right here. And as you may already notice, connecting these 3 points, I have my line. So then you just have to compare your graph with the choices given, and hopefully if you graphed it neatly, you'll be able to identify a match. Let's move on to the next question. So we have 20, and it says find any intercepts and then graph the linear equation. So our equation is -3x minus 12y equals 12. And whenever you are asked for intercepts, you should remember to plug in a 0. So when looking for the x-intercept, you should plug in a 0 for the other variable, which in this case is y. So we have negative 3x minus 12, and then for y we're going to plug in a 0, which equals 12. So solving for x, we get negative 12 times 0 is just 0 or gone. So we are left with negative 3x plus or minus 0, doesn't matter, is equal to 12. So let me just rewrite that, taking the 0 out and then dividing by a negative 3 on both sides to get x by itself. And 12 divided by negative 3 is negative 4. So the x-intercept would be a negative 4, comma 0. Remember, for our x, this was our x value, our y value. We got negative 4, and we plugged in a 0 for y. So that would be our x-intercept. And to find the y-intercept, we basically now plug in a 0 for x. So doing the whole calculation again. So this time, negative 3 times 0 minus 12y is equal to 12. Remember, anything times 0 is 0 or gone. I don't need it because I got something else on the left. So the only thing I have left is negative 12y, which is equal to 12. Now getting y by itself, dividing by negative 12 on both sides. And I have y is equal to 12 divided by negative 12 is negative 1. So I plugged in a 0 for x, and I got negative 1 for my y, which represents my y-intercept. So using the intercept as a method to graph, we just plot these 2 points on the graph. Remember, this is our y-coordinate, and this is our x. And then starting with my x-intercept, so negative 4 on the x-axis, 2, 3, 4, and then 0, so neither up or down. The point would be just here. And our y-intercept is 0 on the x, so going nowhere, right or left, but negative 1 for y, so going down 1. And the reason why they are called intercepts, you may see now, is because they are exactly on the axis. And that's why we are able to plug in zeros to help us find those intercepts, because the opposite variable will always be a 0 on the intercept that you are looking for. So connecting these two intercepts, we have our straight line, and this will be our graph. Again, you will have to match your graph with the choices given to then find the one that closest represents your work.
Alright, for number 21, this says find the slope of the line or state that the slope is undefined. So for this question, we can tell visually that this is not an undefined slope, because an undefined slope is a straight up and down line, like so. So automatically we know this has to be some value of slope. So we're going to choose 2 points that go directly through. See these little dots? It needs to go directly through those dots in order to be a point on our line. So I will choose, actually we have some easy ones right here. We've got one on our x-axis and one on our y-axis. These are actually our intercepts. So this one would be 1, 2, 3. That would be negative 3 comma 0, because that's our x-intercept. And then we also have 1, 2, 3, 0 comma negative 3, because that's our y-intercept. Alright, we have negative 3 here and negative 3 there. So using those 2 points, we will actually find the slope. Now, we can do this either using our formula that we used before, or we can use our counting method. Either one works. So I'm going to do both. So let's first use the formula method, and we're just going to plug these values into our slope formula. So we start off with our y2, so we have negative 3 minus 0 on the top, and then on the bottom we have 0 minus negative 3. So on the numerator we have negative 3, and on the denominator these two are positives, because we multiply them together gives us a positive, we get positive 3. So our slope ends up being negative 1 when you simplify the fraction. Now we can also find this slope by counting. Now remember, slope is rise over run. So what we'll do is we'll count from this point to this point using that idea of rise over run. So we're first going to go down 1, 2, 3. So down 3 is minus 3 to get in line with the point. So that would be minus 3. And then we're going to go to the right. 1, 2, 3. That's positive 3. That would be our run to get to that second point that was right there. And again, you simplify it, and the solution, the slope, would be negative 1. So in the end, our slope, m, equals negative 1. All right, let's move on to number 22. So this one says, find the slope of the line. Now remember, our slope-intercept form is y equals mx plus b. Now our m is our slope, our b is our y-intercept. So in order to check what our slope of a line is, you want to put it into this form. So let's look at this. We have y equals some number x plus some number. So it's already in slope-intercept form. So all that you need to do is look at it, and you can see that your slope, m equals negative 6 over 7, would be your solution. There's no work required. You just had to know what your slope-intercept form was, and then recognize that this is already in slope-intercept form. So let's move on to number 23. This one says find the slope m and the y value of the y-intercept b of the line with the given equation. So what they want us to do in this problem is to solve for y. So we want to get this y alone and isolate it. So in order to do that, we need to move this 12x to the other side. So we will do that by subtracting the entire 12x from both sides. Now over here, these cancel out. We're left with y equals, and what I'm going to do is I'm going to write negative 12x first plus 11, because remember, slope-intercept form is y equals mx plus b. So they want us to put it in that form and then tell them what is the slope and what is the y-intercept b. So our slope is negative 12 and our b is 11, and that answers the question. Number 24 says graph the linear equation using the slope and the y-intercept. So again, slope and y-intercept. It's already in slope-intercept form for us, so we know that our b is 2, that's our y-intercept, and our slope is 1 over 4. So we're going to use this information in order to graph this linear equation. So the first step is to always plot your y-intercept, because that's the easiest one. It's just a point right on the y-axis. So remember, this is our y-axis, and this is our x-axis. So we put a point right there on 2, and now we're done with that, but we still need to use this slope. Now remember, slope is rise over run. So we're going to count from this point, we're going to rise, and then we're going to run. So it says positive 1, so we go up 1, just like that, and then we run 4, so that's positive 4. So going 4 in the positive direction would be 1, 2, 3, 4. And we plot a point right there. After you do both rise and run, you need to wait until you've completed both steps to draw your point. So now we go ahead and we draw a line through these 2 points. And that would be our graph of this linear equation. All right, moving on to number 25. This says solve. When making a telephone call using a calling card, a call lasting 5 minutes costs $1.65. A call lasting 12 minutes costs $3.40. Find the rate of the telephone call. So this is asking for rate. So whenever they ask for rate like that, that typically means that they want you to use this slope formula. And they give us 2 points. So they tell us we have minutes and we have cost. And that's going to be our points. So our first point is 5 minutes for $1.65. And our second point is 12 minutes for $3.40. So we're going to label these points. So we have x1, y1, x2, y2. And then we're going to use our slope formula, m equals y2 minus y1 over x2 minus x1, to find what the slope would be. So let's go ahead and plug in our values. So we have 3.4 minus 1.65 over 12 minus 5. And since you're unable to use calculators, let's go ahead and do this let's actually work this out. So we'll have 3.40 minus 1.65, and we're going to need to carry a little bit, because we can't take 5 from 0, so that becomes 3. Carry a 1. So we have 10 minus 5 is 5. We're going to again carry. 13 minus 6 is 7. Bring down our decimal point. And 2 minus 1 is 1. So we have 1.75 over 12 minus 5, which would be 7. So we're going to actually have to divide this. So we're going to have 1.75 inside the box, divided by 7. Bring up your decimal point. Don't forget that. And then let's go ahead and do our long division. So 7 does not go into 1, so we put a 0 there. But 7 does go into 17, and that would be 2 times. So 2 times 7 is 14. Subtract it, that gives us 3. Bring down our 5. 1 minus 1 is 0, so nothing's there. And 7 goes into 35 5 times. 5 times 7 is 35. And we subtract it, and that zeroes out, which is what we wanted. So it says find the rate of the telephone call. So the rate is equal to 0.25 or 25 cents per minute. Now our final question, number 26, is a bonus question. So it says, list the elements of the set. Alright, so this right here is an intersection. Now what that means is that we want to find elements that are contained in both sets. So we also have something called a union. And when you see that, that just means that you just take everything. But in this case, we have the upside down U, the intersection, and that's the things that are in common. So one way to do this is you can draw actually a Venn diagram if you'd like. Sometimes that's a little helpful. So we're going to go ahead and list these out. These are actually in a nice order. They're all increasing, so we can easily see which ones are contained in both. So 1 is only in this one, so we'll put 1 in there. 5 is in both of them, so that goes in the middle. 14 is only in this one, so we put it over here. 18 is in both, so that again goes in the middle. 21 is in both, and then 26 is just on this side. So when it says list the elements of the set, the intersection would be 5, 18, and 21, and that would be our intersection. Alright, so that concludes our study guide for Test 2 for MAT 0022C. We hope that this was helpful and that you enjoyed watching. Have a good day.